Let's try and solve this equation. This is actually an indices question. So there are lots of ways of doing this, and there are more efficient ways of doing it. I just want to show you what you're able to do, and I want to do it in a way that you could understand what's going on. So whenever you see to the power of a negative number, you can jump to. So for example, if I were to ask you what's 2 to the power of negative 3, you don't understand what it means to have a power of a negative, so you would jump to 1 over 2 to the power of the positive version. So whenever you see to the power of a negative, you don't really understand what it means to have a power of a negative. So you would jump to 1 over x to the power of the positive version, just like over here. So that would then be 1 over x. This 27 gets multiplied to the top. So that would then be 27 over x. So this thing here becomes this. And whenever you see it to the power of a negative, you don't understand what it means to have a power of a negative. So you would jump to 1 over x to the power of the positive version, to the power of a quarter. So now, remember, there are lots of ways of doing this. You can take the reciprocal of both sides, because when you have an equation, you can add equally, take away equally, or you can take the reciprocal of both sides. So now this will then become 27 over 27. This will then become x to the power of a quarter. And there are more efficient ways of doing this, but I just want to do it in a way that you can understand what's going on. Times both sides by 27, so that would then be 27 x to the power of 1 over 4 equals x. So this complicated thing here really boils down to this. And then now we want to group all the x's on one side. So divide both sides by x to the power of a quarter. So that would be 27 equals x divided by x to the power of a quarter. And remember, whenever you have x to the power of a over x to the power of b, that equals x to the power of a take away b. So all we need to do is get 1 take away a quarter. So that will then be x to the power of 1 take away a quarter. But what is 1 take away a quarter? So a blank space somewhere, 1 take away a quarter. Turn this into a fraction. Times top and bottom by 4. So that will be 3 over 4. 3 over 4 equals 27. So now, whenever you see to the power of a complicated fraction, you can break it up as x to the power of, hang on. So from here, you can break it up as x to the power of a quarter, and then to the power of 3, or you can break it up as x to the power of 3 to the power of a quarter. And the reason why you're able to do that is because, remember, x to the power of a to the power of b, that equals x to the power of a times b. So whenever someone gives you a complicated thing, you can break it up as one thing times another thing. Look at 3 over 4. I can 3 over 4, well, this times this will give me 3 over 4. This times this will give me 3 over 4. So really, from here, you can branch out into 27 equals this, or 27 equals this. So from here, you can either choose to work with this, or you can choose to work with this. So now the question is it easier to power both sides by 4, or is it easier to cube root both sides? Which is easier? Well, it turns out that this is easier. So let's work with this. Let's cube root both sides. So cube root of 27 is 3. Cube root of this will be x to the power of 1 over 4. 1 over 4. And then now to get x on its own, power both sides by 4. So this will be 3 to the power of 4, and this will be x. Remember, you're multiplying by itself 4 times to get rid of this to the power of a quarter. So that would then be this thing here. So the answer is 81. 81. So x equals 81. Okay.